Alright, ladies and gentlemen, here we go. Scientific inquiry and measurement. One very scary thing about this new digital age is my voice is going to be following you everywhere now. Perhaps I'll try to find a modifier to make my voice sound more pleasant. Scientific inquiry and measurement. First 2 weeks of school, we went through the scientific method, in which we think about the information we already know. From that information, hopefully, questions are forming in our brains. From those questions, we create a testable prediction, follow a procedure, collect data, display the data in some form of a graph. We haven't spent a lot of time on that, but we will. And writing a conclusion. Most of our 2 weeks in scientific inquiry is spent trying to figure out the difference between observations and inferences. Observations are things that you see, color, shape, smell, and observations can be even data that you collect in the form of measurement, quantitative observations. So again, we focused on two kinds of observations: qualitative, color, shape; quantitative, observations that include numbers. So if you've been wondering why are we measuring stuff for the last 2 weeks, it's been to practice collecting quantitative observations. From our observations, we can make an inference or a conclusion based on our observation. General inferences, we're not sure if they're totally accurate or totally true. For example, in 6th grade, we had the magic matter maker. I poured in a certain amount of water into the magic matter maker, for short, and tons of water came out. So you observed what I did, and then you were supposed to infer how I tricked you. You were supposed to infer what was inside the magic matter maker. We need to spend more time on this types of variables, and we will. We did the penny experiment, in which we tried to add drops of water to a penny. At the end of the activity, we talked about how we did not control our variables. We had some kids test the head side, we had some kid test the tail. Students put the drops of water in different patterns. Some kids were careful with their drops, some were not. And so when we collected our data, we had numbers ranging from 10 to 50 drops. So we did not control our variables very well. If we were going to redo that experiment to control our variables, we would want to make the pennies as same as possible. Same year, same side. We would want to have control variables such as adding the drops of water in the same way from the same height. If we redid this experiment and we wanted to test, for example, heads versus tails, the heads versus tails would be the independent variable. The dependent variable would be how many drops of water fit on the penny. And our control variables in that experiment would be using the same dropper, having the same person drop the drops, dropping the drops in the same way, trying to control all of those variables that may affect our result. Tim and Moby did a great job explaining types of variables when they tried to figure out why their fig plant was dying. Measurement. Last 2 weeks, measurement. Please don't ever ask me again if we're measuring in centimeters or inches. We use the metric system in science, and hopefully someday all throughout the United States. So teaching measurement using the metric system won't be challenging for science teachers 10 years from now. We should know these prefixes. Remember the Tim and Moby video. King Henry doesn't usually drink chocolate milk. Here is the units for length. Why don't you quietly reflect and try to answer those questions? Remember how Tim would use his finger, even though he had 4 fingers, to move the decimal place over to find the proper answer. How'd you do? We talked quickly about accuracy and precision. Accuracy being how close are you to the true value, and precision how in detail your answer is. So for example, we measured a cube yesterday and trying to determine the volume. Some of you rounded up saying the cube's side was 2 centimeters. I would say you were accurate because you were fairly close to the value, but you weren't very precise in your measurements because you misused or improperly used your ruler, resulting in 2 instead of the truly precise value of 1.9. Remember in the Tim and Moby video when Tim was shooting the baskets and the ball was all over the place, not accurate, not precise. Moby came in, threw the ball in the same place, upper right-hand corner of the basket, but never going in. So he was precise, but not accurate. And then Moby, being Moby, turned around backwards and threw the ball repeatedly into the basket, showing that he is both accurate and precise. Mass. Mass is a measurement of how much matter is in an object, and this unit of measurement is the kilogram, and we were using the triple beam balances. And we also discussed the difference between mass versus weight. And remember in the Tim and Moby video, the Rubik's Cube, if sent to the moon, would have the same amount of Rubik's Cube in it, but it would weigh quite different because gravity is different on the moon. Triple beam balance. I think our key lesson from here is get into the groove. Pause it for a second there to listen to morning announcements. So I think I left off with good life advice being get into the groove. So if you see this, are you going to be able to identify how much this object, the mass of this object? So first notice the middle bar, then the top bar, and then be precise. Measure to the 10th. Talked about length. Base unit of length in the metric system is the meter. Should know our prefixes. Volume is how much space something takes up. We practiced measuring the volume of cubes, and we also used graduated cylinders to measure the volume of the liquids. Look at the upper left-hand corner. Measure at the bottom of the meniscus. Here are other graduated cylinders. Again, try to identify the scale. So each itty-bitty line represents how many milliliters of water. Length times width times height. And I'm a bad boy there because I should have a cube, a 3 above the centimeters. And remember we talked about how to determine the volume of an irregular shaped object. We practice using the stopwatches to measure time. Hopefully you had time to do the activity where you measured the temperature of water, then measured the temperature of liquid or with ice, and then add salt to the mix. And scientists use the Celsius and Kelvin scale to measure temperature. And the Kelvin is the SI unit of temperature. Density. So density is essentially measurement of how heavy something is for its size. So we have two cubes, they're equal volume. That would be the denser object, and density is a measurement of mass and volume. So we did a few things with density. We had the different liquids, and you were trying to layer them so the colors didn't mix. And then yesterday we did a lab where you had those different liquids, put them in the graduated cylinders, you found their mass, and then you did math, wonderful math, to calculate their densities. I'm just going to leave you with this story. Archimedes, I believe, had to determine if this crown was made out of pure gold or if the craftsman was sort of cheaping the king, right, and made the crown out of some other material other than gold. Now, he could have melted the crown to determine if it was gold or not, but that's not a very good idea. So how could he figure out whether this crown was pure gold or some sort of mixture? And obviously you could probably go to Wikipedia to figure this out, but perhaps these tools in your imagination don't exist. And how would you figure out if that crown was pure gold? And we'll just leave you with there. So I apologize, that was about 13 minutes. Hopefully I'll get more efficient with these things in the future. And good luck on our test.